Kao prvo, želim se zahvaliti domaćinima na dobrodošlici. Uvijek je lijepo biti sa našim prijateljima iz iz Crnogorske, paneuropske i makedonske isto. ili u jeziku Franceta Prešerna, kojega imate isto ovdje u Podgorici. Lijepo je biti s vami. Climate change between science and politics. Well, it's not the scientific, neither scientific treatise nor political program, but it's just interpretation of climate change by informed citizen. So if you look climate change in the context of socio-economic context, we are living in the society of fear, where the climate change is just one of those fears. We are living in Orwellian world, where information is manipulated and many civil liberties are restricted. Then climate change is important geopolitical issue of food, water, and energy security. And last but not the least, we are living in Anthropocene, the new period in geological history, where the human activity is shaping our planet. So is there such a thing like a climate change? Yes, certainly. The national symbol of Slovenia, Mount Triglav, lost its glacier. And at that point, we ask ourselves what it will have, what will be the consequence for the society. In my field of research, we investigated groundwater of Slovenia. It is an important topic, since more than 97% of drinking water in Slovenia is pumped from the groundwater. So on the map on the top, you see that the groundwater is quite abundant in Slovenia, ranging in the majority of the country between 300 and 800 liters per square meter. And then we analyzed what the climate change will, how the climate change will influence this resource by modeling. And as input, we used the composition of European models on a change on precipitation and evapotranspiration. And we got assembly of nine model results. So the most pessimistic in the top right shows that there will be less groundwater in the whole country. The median one, it's a mixed scenario, and the more optimistic shows in the lower left that there will be increase of groundwater. So what are modeling results more in detail? Precipitation change is dominant over evapotranspiration change. Groundwater recharge change for Slovenia by most pessimistic scenario will decrease by 8%, by most optimistic plus 6%, median scenario is minus 2%, and regional variation of groundwater recharges between minus 16 to plus 11. So as you see, science cannot give simple answers to the politicians. If you look at the climate change, this slide should be interpreted from the center to the up and down. So on up you have mainstream poll interpretations, and down skepticism poll interpretations. And if we ask what is actually the climate? The climate is the result of all physical processes in atmosphere. And what are the driving forces of it? The most driving force is insolation from the sun to the earth. And when it hits the earth, this energy is radiated, but some of the frequencies are kept, and the infrared part of a spectrum we experience as heat. So it is just equilibrium between energy gained from the sun and loss. So the main greenhouse gases are vapor, carbon dioxide, and methane. But if you look in the geological history, climate changed many times, and the main force was orbital variation of Earth. These are Milankovitch cycles, changing about in 100,000 years. But we experienced some climate change even from the Roman times on, and these minor changes are caused by geological processes like volcanoes and by atmosphere-ocean interaction. And we come here to this anthropogene impact, since by burning fossil fuels, we increased concentration of carbon dioxide, and that causes increase in global temperature rise. So what we have to do is we have to decarbonize, and the decarbonizing strategy of Europe is to be carbon neutral by 2050 by cutting fuel use, fossil fuel use, and to give major role to electro sector. And for our citizens, it's interesting that one of the tools will be electromobility, meaning that from 2031, all new cars in Europe should be electrical vehicles, and electricity production in 2050 will be 80% from renewable energy sources. So we have to look at the classical electrosystem. This graph is nearing 50 years, but it's unfortunately it's more relevant today. Well, the major point is to look at the solid curve, the daily consumption curve. That's the load of the electro system, and it is managed by base load, the energy that is needed all the time in the system. It's provided by nuclear and thermal. Then you have to cover intermediate daily variations by runoff river hydro and thermal, and then some small peak energy needs you cover by pumped storage hydro and peak gas thermal. So if we introduce, so this is a predictable system since the sources are predictable, and we can manage the system. So what happens when we introduce wind and solar? In a classical electro system, we had oscillating demand, but we can provide it by the sources. And in this case, we have now oscillating sources. sorry, I had a terrible night. So the main feature of wind and solar is high production oscillation, ranging for hyperproduction and no production. Production timing is unpredictable, and also it is disturbing frequency stability of alternated current grid, since solar is direct current. These oscillations of wind and solar production have to be smoothed out, and could be done in two ways: by smoothing in time, by huge storage capacities, by pumped storage, hydro and batteries and hydrogen, or energy redistribution in space, like if there is high capacity production in Denmark by wind, you can send electricity to Greece if it needs it. And the problem that it's not discussed very much about wind and solar, there are some problems of decomposition and recycle of these materials. EU is pushing solar and wind, and this one-size policy fits all is not relevant to all countries. Like the wind and solar potential around Europe is variable, so that we have it's wind favorable in North Sea offshore wind farms, and then you have countries with low potential wind potential like Slovenia. Like for solar energy, Spain has really high insolation in vast unpopulated areas, and you have low solar potential in Northern Europe. And some countries even don't need this, since have solid carbon neutral baseload production, like France, more about 70% is nuclear, or Norway, which is hydro. Here is case study Germany, and on the way we can learn some nice German words like Energiewende, Dunkelflaute und Verschlimmbesserung. So starting from 2011, they started to phase out nuclear and increased wind and solar capacity. So this loss of base load from production from nuclear, they had to replace by increased thermal, first increased thermal, gas thermal, and with loss of gas during the because of this geopolitical situation. Now that they burn coal, and they increase. Can you open it for me? Increase carbon dioxide. German grid, as a result of it, is very unstable, and it was several times on the brink of blackout, and even small Slovenia helped to save it. As I said, they are facing recycling and decomposition problems. And there is one example. In summer 2021, in the same summer, at sunny and windy day, 72% of electricity production was from wind and solar. But on calm night, the same summer, they experienced Dunkelflaute, where the production was less than 1%. So that's example of Verschlimmbesserung, but I'm sure that they will be able to fix it in the future. So what would be agreeable decarbonization scenario? There will be major energy policy shift to electricity-dominated system. by sources from renewables, hydro, wind, and solar, baseload by nuclear power. There will be need for huge storage by batteries, pumped storage, hydro, and production of hydrogen. And there will be need of international, flexible, stable, and electronically enabled grid. And very important number is on the bottom, 45% of all investment should be into the grids. Here's example what should be rational approach for Slovenia decarbonization. Slovenia should use relevant resources, both energy resources and natural resources. So electric sector in development will need increase in nuclear power, increase in runoff river hydro, increase in pumped storage hydro and batteries, huge upgrade of the grid, keep peak gas thermal as emergency backup, limited solar, very limited wind, and at the end, phase out coal thermal. And Slovenia should take advantage of one of the most of the forests. It's one of the, with 60% of territory forest. It's one of the most forested countries in Europe, and it's a big carbon dioxide sink. So we should keep on Slovenian model of environment-friendly forestry and redevelop strong wood industry. Since if you use wood as a building material or for furniture, you capture carbon in wood for decades or even centuries. So far, that was the top-down approach, and we should now ask what could be the bottom-up. That's the famous quote from John F. Kennedy. I heard it when I was 13, and I remembered it for my whole life. My fellow Americans, ask not what your country can do for you, ask what you can do for your country. So what I did for my country, 10 years ago, I improved energy and carbon footprint of the house by installing thermal insulation and energy efficient windows as passive measures, and as active measure, switch to electrical heating system using heat pump. When you buy 1 kilowatt input, you get 3 to 5 kilowatts of energy. And now I am purchasing electricity 100% from solar source. But as you can notice, the most important information is always on the bottom. I kept my wood stove as backup. As you know, we Slovenians as Alpen folk, we are very rational. And I would like to end up with pan-European message. Europa es el único continente que tiene un contenido. It's quoted by Jose Ortega y Gasset. Or in my mother tongue, Evropa je tista enkratna celina, ki ima vsebino. So I'm calling on the citizens of Europe to do our best in saving this unique continent. Thank you.